Okay, thank you. We are developers. As he mentioned, my name is Lori Olson. I've been a developer for many, many years, maybe even longer than some of you have been alive. I've also been a trainer and a mentor, and now I have a new venture, the Windex School of RubyMotion coding. So I think we'll start with the question, why RubyMotion? Why would you use RubyMotion to do your mobile development? Well, because RubyMotion is Ruby. And, well, Ruby is like my favorite programming language. Out of 30 years of developing, I've used a lot of languages. Ruby is a dynamic, open source language with a focus on simplicity and productivity. It has an elegant syntax that is easy to read and easy to write. Since I'm not going to assume that all of you at this conference are familiar with Ruby, like you would be at a Ruby conference, I'm going to explore Ruby just a little bit further before we move on. And I'm going to address a confusion that people often have, Ruby versus Rails. So Ruby is to Rails what Python is to Django, or PHP is to Laravel. One is a language, the other is a framework. So Ruby is not Rails. So first, I'd like to tell you about a few of my favorite things about the Ruby language. And there's a lot to love about Ruby. First of all, the Ruby philosophy is to make programmers productive and happy. Be honest, people. How many other languages actually have that as the language philosophy? And in Ruby, everything is an object. So what does that mean? Well, let's start, for example, with numbers. Nice, simple numbers. But numbers are objects, so you can do things like call methods on them. You can turn a number into a string by calling its toS method. You can get the next number by calling the next method. Rails added some cool new duration stuff to number, so you can do things like for.days. Gives you a duration that you can use in math with dates. And you can do that same thing with months, years. So that kind of thing makes it really nice to read and write. Another thing that Ruby does really, really well is DSLs, or domain-specific languages. In fact, it's so good at doing domain-specific languages that you will find them throughout the Rails community. The whole ecosystem is filled with DSLs. Let's take, for example, Rake. And this is the late Jim Weirich who wrote Rake. Rake is Ruby's build tool. This is the equivalent of make, which some of you C developers and C++ developers will be familiar with. It's also used as the RubyMotion build tool. So you can customize your project's build any way you like. Now, the great thing about DSLs is you can make them very specific to what you're trying to do. So let's look at a Rake example here. This is the definition of a Rake build task. One-liner description, you define your task, you give it a name, and then you have a code block where you can put any kind of Ruby code that you want. In fact, Rake files are just Ruby. So you can put any Ruby code in there that you like. You don't just have to use the DSL. And when you invoke a Rake task, you just say Rake name of task. And as long as you have a Rake file with that task in your current directory or a directory above you somewhere in your stack, it will find it. And your Rake tasks don't have to be simple. They can be really complex, like this one, where you can have arguments, and those arguments can have defaults. And then you invoke them with Rake task and give it some parameters. Okay, moving on from DSLs, let's talk about iterators. Now, iterators are just some of my favorite things in Ruby because they're so built into the standard library that there's so much boilerplate kinds of code that you never have to write. Let me give you an example. I have a new co-op student, first-year computer science student, and he's learned C++. Now, he came to work with me for the summer, and he's going to be doing Ruby. So I gave him some exercises to try, and this was some of the code that he came up with. This was a fairly simple thing, a command line response where we want to compare against a set of valid options that are in the titles array, and you could also accept back as an option. Now this works, don't get me wrong, this works in Ruby, but this isn't Ruby. This is C++ in Ruby. So I went back with my student and we reviewed some more of the Ruby standard library, some more functions, iterators, and he came up with this. This is Ruby. This is what it should look like. You don't have to write involved loops. You can use an iterator type function like include. This code doesn't just look better because it's shorter, it also reads better. I can come in here and read this out loud and say, we're going to get a response from the user. And then we're going to see, by looking at titles, to see if it includes the response or if the response is equal to back. And then we have valid input. You can't do that with the previous set of code. OK, so that's enough about Ruby. Let's go back to RubyMotion. Now, some of you might be going, OK, so why would I use RubyMotion instead of, say, Objective-C or Swift to do my mobile development on iOS? OK, so here's Swift. Here is Swift's history. Since 2014, there have been 4 major versions. I have every bit of faith that they're going to come up with version 5 in just a few weeks. And the thing is, they're moving very fast. And we all know what moving fast means. It also means they're breaking things. Every major release breaks things. And that means that you, as a developer, are going to have things broken in your apps that you're still working on every year as you try to upgrade to a new version of Swift. That level of change imposes a burden on applications, on developers, that isn't always sustainable. So what about Ruby? Well, Ruby has more frequent updates with minor releases, fewer breaking changes, and it's been around for 25 years, and we're only at version 2.5.1. Now, the creator of Ruby, Yukihiro Matsumoto, or, that's really too long, we all call him Mats. Mats once said, for me, the purpose of life is partly to have joy. Programmers often feel joy when they can concentrate on the creative side of programming. So Ruby is designed to make programmers happy. I have to confess that having used Objective-C even before iPhones existed, I can't say there's anything resembling happy involved in programming in Objective-C. Sorry for those Objective-C programmers out there. But back to RubyMotion again. OK, so the other ways in which RubyMotion is different from programming with Objective-C or Swift. When creating a RubyMotion application, we create them from simple command line tools in your terminal. You're not trapped within Apple's ecosystem, the Xcode environment. Xcode is never going to win any prizes as the developer's favorite IDE. It's just not that friendly an IDE. And the thing about using the command line is that this makes RubyMotion environment really friendly and accessible. At the RubyMotion conference I went to a couple of years ago, I met not one, but 3 blind developers there who love RubyMotion because they can develop in it really easily. Another thing that RubyMotion comes with is a REPL, the read, evaluate, print loop. Now, the REPL allows you to write code in the console when your applications are running on your device or in the simulator, and you can see the changes in real time in your running application. This makes it super simple to experiment and iterate with your applications. RubyMotion also has a baked-in testing framework. It's actually called Bacon. Bacon's my favorite. Anyway, and it allows you to write functional and integration tests by default with your applications. It even comes, all the templates even come with a default test written for you. And we've been developing experience with developer pain points. One of them is deployment to actual devices and deployment to the App Store. So RubyMotion has come up with 2 Ruby gems, motion provisioning and motion App Store, to make it really simple to provision your development devices, your phones, your iPads, whatever you want to use, and get an app on a real device. And Motion App Store helps you get your apps up in the App Store in a similar, easy process. So in a nutshell, RubyMotion is native. It's not emulated like React Native. Ruby is a language of many implementations, okay? There's MRI, or Matt's Ruby interpreter. There's JRuby that runs on the JVM. There's mRuby, which is made for embedded applications and has its own compiled bytecode. And then there's RubyMotion. Now, RubyMotion is not free. I will say that. However, you can start for free. There's a starter edition that lets you use RubyMotion for absolutely no cost. And, because it's not, Apple stuff, sometimes, yeah, you have to wait for updates. For example, when Apple unveiled their new MacBook Pro with the Touch Bar, it was October 27th, 2016, and you had to wait for a version of RubyMotion that supported that new Touch Bar. That was released on October 28th, the next day. So RubyMotion has been really good about staying up to date on the latest, greatest APIs at all times so that you don't have to wait for things. As I mentioned, the starter edition is free. There's an indie edition and a professional edition. The starter edition does have a few limitations. There is a splash screen that you can't get rid of, and you can't use beta editions of any APIs, SDKs, no old versions either. Only the current versions are supported. But you can do development with Starter Edition, with iOS, Android, and now macOS development. That just came with the latest release. They actually put macOS development into the free Starter Edition. And of course, if you use the indie or professional versions, you can also do fun development with watchOS for Apple Watches and tvOS for Apple TVs. That's really quite a lot of fun, and we'll be seeing that a little later because I have a demonstration. And of course, there's Android. RubyMotion can do Android development. And I'm going to have to apologize here. I don't have enough time to do all of this today. This was supposed to be a 4-hour workshop, and I got cut down to a 45-minute talk. So moving fast. And then there's all the Ruby tools. We have Ruby tools like Rake, which we already talked about. There's Ruby gems, which are all the libraries that provide functions for web access, integration with social media, mapping, data access, screen layout, and so many more. And Bundler, we can use Bundler to keep all those gems together in your project and keep all the versions compatible with each other. And you do not need to use Xcode. You do, however, have to have Xcode installed. Sorry about that. But RubyMotion uses the command line tools and simulators that are hiding under the covers of Xcode. But you can use any old editor you want. So if you like Vim, use that. If you prefer Emacs, Sublime Text, or maybe a full-featured IDE with RubyMotion support like RubyMine, you can use that. There's also a curated set of specific to RubyMotion gems under Motion Toolbox. So you can find gems for your RubyMotion development. And if you can't find a gem that does what you want, you can always use CocoaPods. Through the gem called Motion CocoaPods, you can actually embed CocoaPods in your RubyMotion project and just use them like they were a gem. Speaking of which, there's actually a lot of gems and a lot of CocoaPods, and it might be hard to figure out which ones are actually good to use. And wouldn't it be nice if there was a framework like Rails, but for iOS development? And so there is. We have Red Potion. The RubyMotion community got together and combined and tested the most active and powerful gems into a single package called Red Potion that you can install with one command. And this package includes ProMotion to do screens, RMQ to do layout, CDQ for your data access, AF Motion for your network access, and many, many more gems to help you do all your work within one well-supported framework. And so, got through all the slides. Time for the live demo. Okay. Let's see if I can mirror displays briefly now. Yes, okay. Okay, because I'm not totally insane, I recorded this demo, and I'll just talk over it. Okay, so the motion command is what we use to create our RubyMotion applications. You can ask its help for what the templates are that you can use to create the different kinds of things. There's a lot. There are actually, all those templates are open source. We're going to be using the tvOS application template because this demo is going to show you an Apple TV application. So we'll do motion create using the template tvOS and give our application a name called Weather TV because we're going to show some weather information for various locations on the TV. This generates a project with a lot of files. I'm not going to go through them because I don't have time. I will, however, show how a professional Ruby developer manages their Ruby environment for projects. I'm going to specify what Ruby version I want to use in this project. We'll be using 2.4. I'm also going to specify a gem set that I'm going to be using. And that's just one collection of gems isolated for this particular project so I don't contaminate my system Ruby with a bunch of gems that aren't directly related to system functions. Okay, now when we move into that directory, it's going to set us all up, and that gem set is created. Now, every template comes as basically a working Hello World type application, so you can just run Rake right away and get that application up and running in the simulator. This, okay, I cut out a bunch of time here. The simulator does take a while to start, but there you go. You have an application. It has 2 tabs. We'll just exit out of there and wander over to our source code. And I'm going to use RubyMine here. Now, no, the JetBrains guys aren't actually paying me to do that. I actually like using RubyMine. So we'll look, this is the source code. And now this source code is very Objective-C-like. We won't be using this code. I'll just point out that we had 2 screens that it set up, and then it used a tab controller so that it created a tab that you can use to select between those 2 screens, and then we used that tab controller as our main window. We're not going to do that. We're going to use a CocoaPod. This CocoaPod is called CZ Weather Kit. It's a nice little thing that lets us do go out to the web and get the current weather conditions from, wherever. And it's a CocoaPod. And it comes with tvOS support. Woohoo! You also want to use the ClimateCons font with that CocoaPod so that you get nice, cool little weather logo, weather symbols with your current conditions. So that's kind of cool. So let's get the project set up with the gems and pods that we actually need to use. We'll start off with our gems. We set those up in our gem file, and the first gem that we're going to use is called Bubble Wrap. This was actually the very first RubyMotion gem, and it just makes some of the standard iOS APIs more Ruby-like and nice for Ruby developers. Then we're going to use Motion CocoaPods, because we're going to be using that CZ Weather Kit. And finally, we're going to use ProMotion, and ProMotion will be our screens that we're designing. Next, we open up the rake file, and we're going to finish setting up this application. One of the things that we're using is locations, places, and that requires using Apple's API called Core Location. So we add it as a framework here in our rake file. Next, we'll set up our CocoaPods. That's just simple app.pod, and then we use a block, and we can list within this block all of the CocoaPods that we want to use, and it's as simple as that to use CocoaPods in your project. Last but not least, we actually have to tell our project about this other font that we're going to be using, the ClimateCons fonts. So we'll just add it as an extra font resource to our project. So speaking of resources, I have a couple of extra resources that we'll have to get to in a moment. But first, let's install those gems that we just listed out in our gem file. And we use the bundle install command. That's pretty common for Ruby. And I know we only put a few gems in there, but they have dependencies on other gems, so we just get them all installed when we do a bundle install. It figures all that out for us. Next, I want to install that CocoaPod that we specified. I've forgotten what the command is to do that, so I'm going to ask Rate, what pod commands do you know about? And it knows about the install and the update command, so we'll use a pod install. And it's just going to go and look in my project rake and find those pods that I specified and install them. And boom, it installed it. Next, I'm going to get the resources I needed. So one, I preset up some locations that we're going to use to get weather from. We'll look at those in a moment. And I had downloaded that font file, so we're going to copy that also into our resources directory for our project. being in the resources file makes them easily accessible by our application. Back to the code. I'm going to create our weather data file now. We need a place to store the weather information that comes back from the API. So this is a simple class, just a plain old Ruby object. And we're going to have adder accessors. This gives us read and write capability for these attributes, for temperature and the weather summary. It's a textual description of the weather. And we also want that nice weather icon. These are the locations. We just copied this file in. I have Vienna, Calgary, which was my old hometown, and Lethbridge, which is my new hometown. So we're going to read that file in now. That's a simple JSON file. It's pretty easy to read in. So first of all, we're going to use, again, a little bit of more Objective-C-like code. I like to sprinkle this in to show you guys just how sort of verbose Objective-C is, where we have to go bundle, main bundle, path for resource, and then give it the name of the file and the type of the file that we want to load at. But since that's a resource, it expects to find it in the resource directory, and it's just going to find it there, provided I spell it all correctly. Next, we need to actually read that file in. I'm going to use bubble wrap for this, because bubble wrap comes with a really nice little JSON module that will just parse that file in and put it into a Ruby hash for us, making it nicely accessible. But first, we have to load it into a data object to read in from that file. So it's going to read the data in. Oops, I forgot. OK, that first call there returned a path for that file. And now we read the data in from that path and parse it into JSON. Notice I didn't save it. OK, I'm going to save it down here. This is a class level method again, and a class level variable. And I'm going to lazy instantiate it so that we only call this reading the file once, and then it's going to save it in this variable. And last but not least, before we leave this class, we need an initializer. So when we create a new object of weather data, it will call this with our current weather data that we get from the API. I'm not going to bug you guys with the details of what the current weather looks like, but 3 of its attributes are temperature, the summary, and an icon. So we'll set up the temperature. And the summary. And then the icon is actually a little bit more complicated, but just a little. It actually comes in as a numeric value, but I need it to be an actual character value so that our ClimateCon's font will be able to see what that is. So it comes in an attribute called ClimateCon, and I'm just going to get the character equivalent of that number. And that, again, is a function on a number that will convert a number to a character. OK, done with the weather data. Next up, we're going to create our weather screen. This will display our information on the screen for us. Now, it's not a simple object. We're going to use ProMotion and use its screen class. We'll have an adder accessor for our weather data. And now we are going to define a adder writer. That's what this is, an adder writer for location. So when we read in those locations, each screen is going to get a location. And I'm going to just assign it into a local, to the class variable called location. And then I'm going to set the title on the screen to the location name. So we had 3 locations in that file, so we're eventually going to have 3 screens here. Let's go back and create our screens. First of all, we're going to change our app delegate into a promotion app delegate. And then we're going to start creating our tabs. Now we'll use this is a method on load that promotion gives to us. So when our app loads, we'll get an app instance and any options coming into here. I'm not going to use them, but they come in. And we're going to create some tabs. We're going to create those tabs from locations. Remember how I love iterators? Here's one of my favorites, called inject. I can inject a value into a loop. I'm going to call that value tabs. And then each location is going to come into this loop once, and tabs is going to come back into it over and over. And I can just add to that empty array and create a whole bunch of tabs from new screens. Another favorite Ruby function of mine, tap. It lets me take a new object that I've just created, and before I give it to anything else, I can do some initialization on it. And I'm going to initialize this screen's location here. Okay, so now we have all the tabs created. All those screens have been created with locations. Now we want to set up our tab screen. So we'll open a tab bar and give it all of those tabs. And that's all we need. We don't have any weather information coming in yet, but we have enough information here that we can actually go out, and I just realized that I made a mistake, and it's called PM delegate, not app delegate. So we can go out and run rake. And again, I am really compressing the time here, guys. It builds all the promotion libraries. It builds all the CocoaPods here. It builds bubble wrap files. It builds everything that you need, and then fires up the simulator and shows us our new application with our 3 new tabs that we created from our data, Vienna, Calgary, and Lethbridge. Okay, now we need to get some weather data in here. And I know we're running out of time, haha. So I do have time, though, to copy and paste code in. So that's what we're going to do from now on. I'm going to copy some code in here, and this is our get weather. And it's just going to make a call out to the weather API. It's a fairly straightforward set of calls. We make a new weather request. We set the location for that weather request to the latitude and longitude of that location that we have in this screen. There's my weather underground key. And then we give it a nice little anonymous function that it's going to call when this request completes asynchronously. This is one little complication here. When you make requests out to the web, they should always be asynchronous. Do not make them synchronous. So we will have to add a little bit of code to deal with that here. But first, let's add in some actual places to put information on our screen. Some labels. Our first one is going to be our symbol label, where our Climacon is going to go, and it's going to be a nice big size using the Climacon font. Then we're just going to have 2 fairly straightforward labels, and we're just defining start, x, y, and size, width, height for these frames for each of these. Okay, after here, we need to do something about this asynchronous stuff. So what I'm going to do is use, once again, something handy from Bubble Wrap. It comes with a really nice wrapper for KVO, or key value observation. And by including that as a module here, I just automatically get a method I can use in this class called observe. And I can observe any attribute of any object I want. So I'm going to observe myself, and I'm going to observe my weather attribute, because when that anonymous function returns, it's going to update my weather attribute. And when observe gets called, when weather changes, it's going to get an old value and a new value. So we're going to load up our weather values that have come in with the new value. And last but not least, in this method, this onload method that gets called once when the screen is loaded, we actually have to, kick off the get weather. At some point it has to happen, right? So it's going to asynchronously return weather, which will change our weather attribute, which will hit our observer, and then we'll need to actually put stuff into those labels that we created. So let's quickly go and copy that code. This has a little bit of debugging in it, just so you see what debugging looks like. I'm just checking to see what that new value that comes in is, and we return if it comes in as nil. Otherwise, we just set the text attribute on each of those labels. One complication is that the temperature comes in from the API as a structure, and that structure has Celsius, Fahrenheit, and some other stuff. Those Celsius, Fahrenheit values are numbers, so we convert them to strings, and we tell the screen that we need to set the layout. I'm also going to load those weather values with our weather attribute in the will appear. Will appear gets called every time we switch from tab to tab and we come back to a screen. Will appear will get called again, so it'll update. Whew. Okay, that's actually it. That's all the code. So it's going to run now, and we have a little bit more compiling to do, comes up, and we get the weather for Vienna, and the weather for Calgary, and the weather for my current hometown of Lethbridge. Come on, you can do it. I've got a little bit of time left. Hey! Whew. Okay. So I am really running out of time here, so I have to go back and gather windows, and stop mirroring displays, and go back to our presentation. Okay, so we finished the live demo. You might have noticed that there's a few things that weren't, 100% there, like the temperature was a big, long, real number. As an educator, I kind of like to leave some things as an exercise, so if somebody wants to go and check out that code, it's going to be up there on GitHub for you, and you can download it and try it out yourself. You can also do things like add waiting indicators, because I have to tell you, I so totally cheated. It actually takes like 5 or 10 seconds for each of those weather API calls to come back. So you can add a nice little waiting indicator, something like that. But the thing is, I came up here to talk to you about RubyMotion, and about the Windex School. The Windex School is my school, and I want to help get you off to a great start using RubyMotion with RubyMotion Jumpstart. It's our introductory workshop featuring RubyMotion and Red Potion that will get you going from installation and setup of RubyMotion to generating your first application screens, adding user interactions, screen navigation, adding data models, populating those data models with data from a remote source, and then getting that app up and running on your own device, all in one class. Now, that class is going to open officially on May 25th. Originally, I was going to have it open today, and then I thought, wait a minute, Lori, you're going to Vienna. You're going to take a week of vacation there. It would be mean to get people going on the course and have you off on vacation. So I'm opening next week. Officially, the course will start next week. But you guys can sign up today. Registration is open on that course, and you will also get a nice little discount at that URL, bit.ly RubyMotion WeAreDevs. And you'll get a discount for this introductory course. Now, this is the very first course. There's going to be many, many more. I have just started working on the Windex School for the last 6 weeks, and I've got this entire year planned out to add new content so that people can learn all about RubyMotion development. So thanks, WeAreDevs, for having me. The presentation with all the links to everything will be available later this afternoon on Speaker Deck.
Thanks, Lori.